In this course, we've discussed trees many times. Tree structured data could be represented either using a list, using the tree data abstraction, which has this constructor and these selectors, and a helper function isLeaf that tells you whether or not a tree is a leaf. Or later in the course, we discussed how you could represent the same thing using a class. In the case of a class, you use attributes in order to record the components of a tree, the label and its branches. No selectors are needed because we just have the attribute names. And the helper function is instead a method, which you call onSelf to tell whether there are any branches. A leaf is a tree with no branches. But these aren't the only kinds of trees, and neither of these are built into Python. That's because the notion of a tree in computer science is an abstract one that generalizes over anything that has component parts that are also trees. The key characteristic of a tree is that a tree contains other trees, and importantly, a tree can contain more than one other tree. We see examples when we look at nested lists. That's like a tree structure, where this nested list contains other nested lists. An expression in Scheme or in Python is also a tree structure. This call expression has operand sub-expressions, which themselves are call expressions. Here's a syntactic analysis of an English sentence. A sentence has a noun phrase, a verb phrase, and a punctuation mark. So that's a whole phrase that decomposes into smaller phrases, which decompose into smaller phrases still. Again, tree-structured data. The way in which the layout of a web page is stored is using a programming language called HTML. The hypertext markup language is tree-structured as well. Here, we see a tag describing an unordered list, which has within it tags that describe list items, and those tags have tags within them as well. Here, this is how you indicate that the one is supposed to be bold. So trees appear anywhere there's hierarchical structure in the data that we try to represent. And tree processing often involves recursive calls on subtrees. So one of the primary reasons to learn about recursion is in order to manipulate tree-structured data.